This is lesson 326, applying similarity. So we're just going to do some word problems here with similar triangles. So this first one is an activity you'll do in class, so we'll just move on to this Big Ben problem. We're trying to take a picture of our dad in front of Big Ben. After snapping the photo, we realized that our dad's head is perfectly blocking the top of the clock. And it got you wondering, how tall is Big Ben? So we should find some similar triangles that will help us determine the height of the tower. What I think I'll do is, I see the camera here, so I am going to kind of make our triangle like this. So that's a triangle that's going from the camera to Big Ben. And then we also kind of have this similar triangle within it that is kind of for our dad. So what I'm going to do is, I like to draw those out separately so that I can see better, but these are the two similar triangles, the one to our dad and then the one to Big Ben. So the distance between where we're starting and our dad is 12, and then the distance, we've got 12 plus 930. So that is 942 from the camera to Big Ben. And then height-wise, I kind of drew over it, but our dad is 6 feet tall, but our camera's 2 feet off the ground. So that means this height within our triangle here, our small pink triangle, what's left over is going to be 4. And then we want to know the height of Big Ben. So we can just set up a ratio for these triangles. I'm going to start with x, and the side that goes with that is 4, and that should be equal to 942 divided by 12. And if I cross multiply 942 times 4, and then dividing by 2, you know what, that should be 12, not 2. So we're going to get 3,768 equals 12x. And then we're going to divide that by 12. So x equals 314 feet. So Big Ben, oh wait, here's the thing though. Just this portion is 314. But reminder, our camera sits 2 feet off the ground. So we actually need to add these together. So that's going to be 316 feet off the ground. All right, just on to some check your understandings. I won't do all of these, but I'll definitely talk about some of them. We've got a tree with a height of 4 meters. So I'm going to draw my little tree here. That casts a shadow that is 15 meters long. So when we measure a shadow, we would measure that flat against the ground. So if we kind of turn that into a triangle, that's what we would have. And then we've got another tree that casts a shadow 20 meters long on the ground. So that's going to be a slightly taller tree. We're pretending that the sun is kind of at the same height in these problems to create the same angle of that shadow. So then we could just set up a ratio here. 4 over x equals 15 over 20. And then cross multiply, 80 equals 15x. So that x equals 5.3 repeating. So the height of that tree that casts a 20-meter shadow is 5.3 repeating. A 10-foot ladder touches the side of the building at a point 8 feet above the ground. So if here's the building, here's the ground, the ladder reaches 10 feet up and the ladder is 10 feet long. The ladder leans, right? So that would be 10. And then at what height would a 7-foot ladder touch the building with the same angle? So here's our building again. Let's do a 7-foot ladder. And we don't know how high up that would reach, so that's going to be x. Let's do 10 over 7, 8 over x. So 10x equals 56. And so x equals 5.6. The ladder would reach 5.6 feet up the wall. All right, moving on to medium. Roger wants to find the height of a flagpole. So here's our flagpole here. Roger's 5 feet and 6 inches, so that's like 5.5 feet. And casts a shadow that's about 3 feet long. The flagpole casts a shadow about 11 feet long. So let's do the flagpole here, 11 feet along the ground. But then Roger, who might be over here, he's 5.5 feet tall, and he casts a 3-foot shadow. So we've got 2 triangles here, and we want to know how tall the flag is. So Roger's 5.5, the flag is x, and then we've got 3-foot shadow and 11-foot shadow. So 5.5 times 11 is 60.5 equals 3x, and then divide both sides by 3. X equals 20.17. So the flagpole is 20.17 feet high. And then let's go on and just do one spicy together. Another ladder problem. A ladder that is 250 centimeters tall leans against a fence. So there's our 250-foot ladder. Leaning up against that is 150 centimeters tall. Another ladder is leaned up against the same fence, but it only reaches up 100 feet. So like 100. And we want to know how tall that ladder is. So what we could do is make 2 different triangles here. If that seems better, 100. Not sure how tall this ladder is. So let's call that x, actually. So 250 over x, and that should be 150 over 100. I'm going to cross multiply, so 250 times 100 is 25,000. That's 150x. And then I'm just going to divide both sides by 150, so x equals 166.6. So the ladder is 166.6 centimeters.